So today we are going to solve this clone graph question in LeetCode. So first we will read the question what it says. So given a reference of a node in a connected undirected graph, return a deep copy of the graph. So we know that what graph, there are two kinds of graph, directed and undirected. Directed means going from one node to another with an arrow, like outgoing arrow or incoming arrow is there. But in undirected graph uh, there is no specific outgoing and incoming arrows. Like every node is receiving arrows or sending the arrow. It is like this. And deep copy means, so if I explain in terms of Python, so there are two kinds of copy. Okay, first is shallow copy and second is deep copy. So what is shallow copy? Shallow copy means that we make a reference or we make a new reference to the original object that is there. So suppose we have an array 1 2 3 4 5. So we make a reference to that whole array or object inside that array. Okay, so like uh, for an example, if I say we have an array 1 2 3 and we make a shallow copy of that array. So in Python only it is there, like you directly create array dot copy and there is you got the shallow copy of that array. And if you change the, like suppose if I change index 1 value, 1 2 3 are there, so if I change it to array 1 equals to some 4, so and when I print the original and the shallow copied array, they both are same. Why? Because shallow copy creates a reference and it is referencing to the original array itself. So whenever I change the value here, it will go directly reflect in that in the original array itself. So both print the updated value. Both arrays are printed in with a updated value. But if I create a deep copy there, so deep copy won't copy the whole won't alter the original list. Okay, it will just create a independent copy of the what you can say the original array. Okay, so like uh, in here both the inner and outer objects are copied, and shallow copy it is not like that. Okay, so we understood the basics of what is deep copy is and what is the undirected graph says. So now we have this, each node in the graph contains a value and a list of its neighbor. So we have this class node where we know that the value is this. So this is a class, right? So you know the definition of a class, or what is class and what is inside this public and all. So I will not go in details for that. This is already pre-written code. Okay, and so first thing is like for test case format we have this. For simplicity, each node's value is the same as the node's index. So for like if I say 0th index, so 0 node is there. First index means first node. So for example, the first node is value 1, the second node is value 2, right? Like so. Okay, and the graph is represented in the test case using an adjacent list. Adjacent list means the list which contains the neighbors of the node. So like typically or generally we store the neighbors of a node in an adjacent list. Uh, yes, so that we can traverse all the child nodes from sitting on the current node. Okay. Uh, so an adjacent list is collection of in-order list used to represent a finite graph. Each list describes a set of neighbors of a node in the graph. Yes, that's what I said. And the node will always be the first node with value equal to 1. You must return the copy of the given node as a reference to the clone node. Okay. So, uh, so now we will go to the code. Okay. So now we have understood like what is the question is asking. Okay. So we have a graph. Original graph is given. Okay. So there is this original graph. This is the original graph we have given. Now we have to create a deep copy of this, like the original copy. Okay. So like okay. So now we will go with the code. Okay. So how to code it? So first thing that comes to our mind, the base case. What is the base case? Base case should be like if there is no node present in the graph itself. So what we copy? Nothing. So if not node. So we will return a null pointer. Okay. Now, so now comes a interesting part. What? So we have known that okay, we have the nodes. Now, where are the nodes, right? Where are we collecting the nodes? We have to create a reference, and for that reference, we have something to store the values, right? So, so, so what comes to our mind? So like, okay, I have to store a value, and while inserting and picking the elements, it will take big of one time. Why? For my convenience, right? Yes. So what is that data structure that comes to our mind when we are thinking about this? Yes, that is map, and uh, specifically saying unordered map. Okay, so we will create an unordered map uh, for node. Sorry, I wrote node. MP. So we now have the map. So in that map, we will store the, we will keep the nodes there. Okay, with their cloned nodes. Okay, right. So this is the base case, and another base case is what should be the another base case? So think about it. So like we have the node. We don't. If we don't have a node, we have to return one point because nothing is there. And to avoid confusion and to reduce the what uh, to reduce our like efforts, like if we have already cloned a node, then why should we clone it again, right? Or why should we keep it in the map itself, right? There is no such need for that. Okay, so again we come up with the idea like if the node is there in the map itself, then we have to just return it. Okay, just return the node. If it is already cloned, then why should we have to again clone it and insert it back into the graph itself? Okay, sorry, map itself. Now, okay, the base cases are done. There is nothing left to like trigger, nothing left to think about anything other than this. So now we come up with the deep copy. What is deep copy? We create a reference of the inner and outer object both. So we create a node called cloned node, which has the current node value. Okay, the first node we start from value equal to 1. That what question says. So now we create a clone node and we store that clone node into the map itself, right? You understood up to this? Uh, so uh, now we know that it is a undirected graph, right? So undirected graph means there are neighbors, right? And yeah, what should we do in case for the case of neighbors? How should we traverse them, right? We have to traverse in the proper order. So yes, okay. So we have this in our class definition. So let's look for the class node. What is there? So we have this value, okay, and we have this neighbors, right? So neighbors, what it contains? So neighbor contains the neighbors of the current node. So we have that neighbors in the vector stored here. Okay, in this vector, we have the neighbors stored for this current node, whatever the node I'm saying. This is not, this is classes, right? So we have the neighbors. Now we know that we have a neighbor. So what we do is we traverse through the neighbors and the for the current node and like iteratively or recursively. Okay, so there comes recursion, or recursively we will traverse all the neighbors of the neighbor nodes, right? What I'm saying, it's like you are starting from one point and creating a butterfly effect, like it's affecting all the connected nodes throughout the whole graph. Okay, so now we will go with for auto. Why we set it auto? Like we don't know what it should be. Like in this case, we know that it is a node. So okay, let's change it to node star. Now we go to the neighbor. So what is the neighbor? Neighbor is node neighbor, or uh, yeah, node neighbor. Node neighbor, right? Neighbor. Sorry. So now we got the neighbor for the node. Okay. What should we do with this? Here we have created a reference, cloned reference, right? So in that cloned reference, we have to insert, or we have to connect it to the neighbors. So we will do clone neighbor dot pushback. What to push back? We have to recursively traverse through all the other given nodes, neighbor nodes in the graph. Okay. So what is that? Name neighbor. Okay. So now we will return the clone part. Now it is cloned. So we will check it. We will check if it is running or not. So there comes a compilation error. What it says? So we have this classical node definition. Okay, previous definition is there. Okay, so this is the redefinition of the node that we are getting error. Okay, right. So this is the part which was copied. So explain how we have to comment it. The rest everything is fine. I think it should run. Yeah, let me expand it for you. So okay, it ran, and yeah, we got the, so like this is the base case where no node is present, so we will output the null pointer itself. Okay, and this is also that case. This is the original graph that we had, and we copied it to the, and we copied it exactly as it is using deep copy. Okay, right. This is a question. Uh, yeah. So if you have understood it, it's well good for you. If you don't, then please write comment. What should I have to improve, or what is there that you don't understand? Okay. Thank you.